So find this task from last week. We're going to take about 5 minutes to go over it. Graphing calculators out would also be good because we will be using them momentarily. At the miniature golf course, you come to a hole where you must hit the golf ball off the wall in order for it to have a chance of going into the hole. We're given the model, which is fantastic. V equals -1/2, and then in my absolute value bar is D minus 10 plus 5, where D is the horizontal distance of the ball and V is the vertical distance of the ball. Imagine you are looking at the course from above. So you have like a bird's eye view. Let's first define variables. Who's got variables for me? Horizontal distance? Yes. How is the horizontal distance being measured? What's my unit of measure? Does it tell me? No. Can we reason on what would make sense? I don't know. That looks like a pretty decent length. Let's go feet. And V is the vertical distance of the ball, or as you put it, which I like. What'd you say again? Height off the ground. Height off the ground. Okay, very good. Let's talk about graphing. Tell me what to do. How am I going to graph this? You have to find the vertex. Great. What's the vertex? 10, 5. Vertex 10, 5. Good. We talked about how we can set this up or realize that we're really just being given the first quadrant. How did you guys count? 2? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And we'll put our labels. This is horizontal distance. How did you guys count on the y-axis? 2's again. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Oh, thanks. Okay, so now we have a framework. We can actually graph our points here. We have our scale, we have our labels, we know what we're counting by. So 10, 4, so 5 will be halfway between 4 and 6. There's my vertex. Now what? Got the vertex? What is A? So we'll start here. Now realize that counting down 1, am I going to go right here or down 1 more? Would where I'm pointing be down 1 or down 2? 2. So we're actually, half a box is 1. So down 1, right 2. Right? Because this box also represents 2. So we have to pay attention to our scale. Half of a box is 1, right? And we're counting by 2s this way and this way. So going to the right, 1 full length of a box is 2. So down 1, right 2. Down 1, notice how I stop halfway. But then to count 2, it's a full box. You follow that? We're just talking scale right now. Are we good with how I'm counting? Who needs me to say it again? I can. Okay. So keep in mind, we're counting by 2s here. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18. So, and then same thing here, 2, 4, 6. So right now I'm at 5. I want to go down 1. If I go down 1, instead of being at 5, where am I? 4. Notice where 4 is. 4 is not down here. What would this be? 3. So to go down 1, it's down to 4. But now I want to go right 2. If I stop halfway, what's that? What's halfway right here? 11, I need to go right 2. So down 1, right 2 puts me right here. Down 1, I go halfway. Right 2, I go over a full box. This is just respecting what we've said is our counting scale. So now to get the other ray, instead of going down 1, right 2, I'll go down 1, left 2, down 1, left 2. Before we start drawing the lines, any thoughts on how we're going to work in this restriction right here? Yeah. So let's see what happens if we actually sketch our graph here very carefully. Do we end up hitting 0 and 20? Zero, 20. Now, we were able to kind of reason on that from the graph, but we can actually calculate this as well. Are these values for D or V? D. Is D the input or the output? Input. So let's see what happens when D equals 0. So V of D, wherever we see D, we're going to plug in 0. So V of 0 equals -1/2, 0 minus 10, plus 5. So we're being given these values for D. All we're doing is plugging them in and seeing what happens. What does this become? I have -1/2. What's inside the absolute value bars? -10 plus 5. What is the absolute value of -10? So -1/2 times 10 plus 5. What's that? Mm-hmm. So this gets me the ordered pair. What's the input? And what'd you get out? Right there. Guess what would happen if we do V of 20? What do you think we're going to get out? Go ahead and try it. V of 20. See what you get. We all get 20, 0? Sweet. Now, don't assume when we have that interval that it will always sit on the x-axis. This is just a coincidence because we're talking about the golf ball traveling from one side to the other. It could be that if my function was somewhere up here, maybe one ends right there and one ends down here. It's not always going to sit on the x-axis. Very good. Domain? Is it? Careful. 0 to 20. Finite start, finite end. Range?
0 to 5.
Very good. So, big picture, when I have a restriction, it's just a quick exercise in algebra to figure out what's the finite start and finite end of the graph with whatever we're working with. When you're ready, let's take out the homework from last night and compare answers. I have an answer key scanned for the back. So on the front, for the front side, just compare with the neighbor. I want to show you what the back looks like. The front, I think everybody finished before you left for class, before you left at the end of Friday. Most people did. Second row, far left. Yes? No, that was purely for you. That way you could take the quiz. Are we agreeing on the first two on the front? Did anybody have questions on the front? So 1, 2, 3, 4, yes. So 4, 4 would fit in right here.
Oh, wait. No, but I was just
Are we matching for numbers 1 and 2 on the back? If not, let me know. We'll talk about them. So for number 2, do we agree the vertex is negative 6, 2? Okay, so from here, we're going to count the right ray first. So I would go up 1, right, up 1, 1, 2, 3. Up 1, 1, 2, 3. Up 1, 1, 2, 3. So here M is 1/3. So just double check. Good? Number 3, I'm going to come back to as part of the review video. So you can check your answers straight up, but I will discuss this question as part of the video I put up tonight. How did we do rewriting 4 and 5? Do we want to go through those together? Okay. So this is the rewriting questions of the homework, and it's a great opportunity for us to recap the notes from Friday. So what did number 4 say? Okay. There's a 2-piece process to this that never changes. And we can even give it a little bit of a label. So if you're struggling to organize your work, we are always going to start working on the right ray first. What do we do for the right ray? Leave it alone. So we are going to actually make a choice to turn these absolute value bars into parentheses. We're going to leave it all alone and actually figure out what expression we get from this. And this is just a quick exercise in algebra. Distributing the -2, what do we get? Good. So that gets me -2x plus 21. Leave that alone. We'll come back to the domain in a sec. Now let's go look at the left ray. What are we going to do for the left ray? Change which sign? The A value, which in this case is what? So -2 is going to become a +2. And again, absolute value bars become parentheses. And now let's figure out what this is. I distribute 2, what do I get? Good. Combine like terms. 2x plus 1. Now, the key piece that we kind of talked about, but I really want to make solid in our brains today, is how do I figure out the restrictions on x? Okay, good. Yes, the h value. So let's talk. What's the vertex of this function? Good. Which means h is 5. That's the key value, okay? This will always be x greater than or equal to h, in this case 5. Always, always, always greater than or equal to. Because it's the right, think about what that means. This is opening down, right? This is always the right ray, what we just did right here. Here's my right ray. If I'm looking at my x values from left to right, we're always going to, when we talk about this piece, When we look left to right, this is always going to be greater than or equal to some value, always. On the flip side, the left ray will always be what? Less than. So now our only job now is just to actually put it together. So f of x equals negative 2x plus 21, x greater than or equal to 5, and then 2x plus 1, x less than 5, and we're done. Good? All right, let's check number 5. What did number 5 say? F of x equals 1/3. X plus 6 and then outside minus 4. Okay, so again, let's break this up. Right ray. Right ray, what do we do? Yes.
That's going to be negative 6, right? So, would we use it as plus 6 or negative?
Leave it just the way it is. Leave it just the way it is right now. When we get to talking about vertex, then we'll say negative 6. But for the equation standpoint of things, don't even think about that. Yes?
Is it possible to have one is with x and then like plus or minus a number inside that?
Yes. But she's saying, could there be more than just x plus or minus? This could definitely be more involved, but for it to stay just being an absolute function value without any crazy other restrictions, that's as far as we're going to go with it. Okay, so for the right ray, what do we do? Do you change anything? No, don't change a thing. All we're doing is saying the absolute value bars become parentheses, and we're going to figure this out. So this is going to equal 1/3 x plus 2 minus 4, which is 1/3 x minus 2. Left ray, what change are we going to make? A is going to become negative. So this will be f of x equals negative 1/3 x plus 6 minus 4. What does this equal? Minus 2 minus 4. Now how do I figure out my restrictions? Look at the vertex. What's the vertex? The key value being which value of the vertex? H. Very good. So here's H. For the right ray, always, 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 it's going to be x greater than or equal to negative 6. For the left ray, it will always be x less than negative 6. And now we're good to go to put all of the pieces together. F of x equals 1/3 x minus 2 when x is greater than or equal to negative 6, and negative 1/3 x minus 6, x less than negative 6. And we're done. That's as far as we need to go with the piecewise application of writing, as much as we're going to do. Right? So to switch gears, I have a quick little warm-up for you to turn and talk for a minute. Get your brains thinking about our transformations and what they mean. So if you want to collect your own thoughts first before talking to someone, do that. Or work on it right away, up to you. Cassidy, one of these is coming back to you. Compare, compare, compare. Compare the graphs. I'm given two different graphs. In complete sentences, state at least three similarities or three differences. I'm cool with bullets. If you want to do bullet points, that's fine. So everything you know about functions, what's the same, what's different? I would take just 3 points, whatever you find, but see how many you can actually come up with. Okay, at this point, turn and talk. The person next to you, see if they have one you can grab that's not on your paper, and vice versa. Can you give them one they don't have yet? Okay, talk to me. What do we have going on here? Michelle? Very nice. For both, k equals 0. So what was the second part of what you said?
They both have 1 point on the x-axis.
So both have 1 x-intercept. Good. That's true. Yes?
It says the absolute is greater than 1, so it's 0.
Absolute is greater than 1. So this one I agree, but I think this is a difference. So first, Bert, let's try that again. First one, the absolute value of A is 2, which is greater than 1. So what kind of graph is that? Narrow or wide? Narrow. Second one, what's A for the second one? What's the absolute value of -1? If I exactly equal 1, starts with an N, not narrow. When something is, I don't know how to get you to think of this word without telling you. It's not wide, it's not narrow, it's normal. Meaning it's not more narrow and it's not more wide. It still matches the width of the original parent function. That's the definition of normal.
You could basically say the second one has the same slope as the parent function.
Yes, and that's the definition of normal. Yes, Ashley. Good job. For both, the vertex is, what was it? -1, 0. Very nice. Yes.
The first one opens up, the second one opens down.
First one, how'd you know that?
I looked at this one in the first one, positive, and the second one is negative.
Good, so first one, positive A opens up. Second one negative a, opens down. Love it. Anything else? Yes, Linda? Yes, we got that one. Third one. Very good. Any others? These are great. We're up to 4. More than 3. Awesome. Cassie? Good job. I think we kind of talked about that one right here. Oh, no, you're right. Okay, so slope. First one, positive 2. Second one, negative 1. Good? Any others? Actually? Both h values. So what does that mean? Both have h equals negative 1. So what does that mean about their graph? What kind of shift is that? Shifted left 1. And the fact that k is 0 means what about vertical shift? No vertical shift. So if you wanted to technically add that to this one, both have k equals 0. No vertical shift. Very nice. Very nice. So this is a nice little summary of all of the pieces of information that you can pull out of a function. Nice job. We're going to switch to a really cool use of your graphing calculator. So get those graphing calculators on. Our first official use of them in class. I am excited. Now, this is actually a solving strategy that came from one of the AP teachers, who also, from time to time, has taught Algebra 2 Honors. And she saw it as like a, well, if they saw this question on an AP test, this is what I would expect them to use their graphing calculators to do. So like in a testing situation, you totally could do this, unless I explicitly asked you to show a certain kind of work. But if I just said solve this, the method we're about to talk about works. Go ahead and go into your, well, let's look at this first. Use the graph below to solve the equation shown. So what we're about to talk about only applies to equations. What I mean by that is, see how we have negative 2 equals function? Yes, and this one, 0 equals. Do you see f of x anywhere on this page? No, it has to be an actual equation, something equals something. So there's going to be a connection here. Connection to systems of equations. Anybody remember break-even equations from Algebra 1-ish? They kind of looked like this, like negative 3x plus 5. Well, like you would have y equals negative 3x plus 5 and y equals 2x minus 1. When does this one equal this one? And then you would literally set them equal. Negative 3x plus 3 equals 2x minus 1. And in a calculator, technically, you could have put this one in and this one in and see where the lines do what? Intersect. The same principle applies here. This is going to be one equation, and here's my other one. So before we actually try putting this in the graphing calculator, let's actually look at the graph. Here is the graph of y equals negative 2. Here is the graph of y equals 2 times the absolute value of minus 6. 2 absolute value of x minus 6. Do you see points of intersection? Where? Give me the ordered pairs. And? Good. Let's realize what this means. my answers for this equation are the x values. X equals -2 and x equals 2. And we're actually going to prove it to ourselves. How would we do this if we did not have the graph? Let's mentally do a check. Let's let x be -2. Watch the screen. If I put -2 in for x, what's the absolute value of -2? 2 times 2? -6? -2. Let's let x be a +2. What's the absolute value of a +2? 2 times 2, or -6, -2. So I have a digital graphing calculator that I'm going to pull up so we can hopefully match. This is my first time ever using this, so bear with me. But how cool is that? Okay, so first I want you to go into your y equals. Set the upper buttons right below your screen, and make sure you don't have any functions in there at all. Make sure those are cleared out. Your clear button is right underneath your arrows. So what's the first equation we're going to plug in? -2. And if you watch, my buttons will come up right here. So I just hit -2. Enter. So that's my first equation. What's my second equation going to be? 2. Now, to get the absolute value bars, you need to look for math. It's here on mine. It should be somewhere in the middle. If your partner's not finding it, help them find it. So math. And then if you go over to if you scroll over, use your right arrow to get to NUM, you'll see absolute values right here, and then you hit enter. If anybody's struggling with that, ask Missy to come over. She'll help you with that. So we hit math, and then we want to get this list of values. So we just hit NUM, and now I'm going to hit enter so I can select that one. Or you could actually hit 1, your choice. Enter or actually hit 1. And now I have absolute value bars. Yours may say ABS parenthesis. Means the same thing. What are we typing inside? X. Now, if yours says ABS parenthesis, what do you have to make sure you do? You have an open, you got to make sure you close it. Like mine, the typeset automatically gave me a bar. If yours is saying ABS with an open parenthesis, make sure you close it. And then what's after the absolute value part? Oh, I need -2 in parentheses?
No, in the absolute value.
Yeah, so x -2?
Oh, wait, I never.
No, I'm right. Hey. 6. Parentheses. I'm going to pause right there. Who needs help getting that far? Yes. Good? Good, good, good. Now to graph, zoom 6. Zoom 6. Zoom 6, it gets you to a standard box. So before you graph, I want you to hit zoom and then 6. We should get that. Can I see?
I gotta clear my other graph. Yeah.
Invalid dimensions. Why is it saying that? Who's getting invalid dimensions? Can I borrow your calculator? Did anybody else get invalid dimensions? I'll have to figure out why. But how many people got this graph? All right, fantastic. If your calculator is being not nice to you right now, just share with a neighbor real quick. The principle applies. So now try this on the second example. Try this on the second example. What? Yes. So you're going to have to clear out these two. So go back to y equals. and clear them out. Clear. Scroll down, hit the down arrow, clear, get them both cleared out. Go back up to y1. What's the equation for y1 going to be? 0. What's the equation for y2? 3. And then how do I get to absolute value again? Math. Go over to number. Enter. X minus 2. X minus 2. Minus 3. Zoom. 6. What are the solutions for this one? 1 and 3? Well, let's test it out. So I'm on the whiteboard here. I'm going to write the original function. So we're thinking x equals 1 and x equals 3. Let's see if it makes the equation true, right? So I've got 0 equals 3, x minus 2 minus 3. What happens if x is 1? What's 1 minus 2 inside these bars? Careful. We get 0? Yeah. Yep. And how if we let x equal 3? So 3 minus 2 minus 3. We get 0 again. So this is an awesome use of your graphing calculator as an equation solver if you have an absolute value equals a number. Yes. All right, let's talk about that. So for the rest of class, we have two things going on. We were going to have a full day to work on an independent practice type 3 for absolute value, and then we have the study guide. The study guide is going to be the priority. This is only happening, or whatever portion of this you want to work on tonight, if you're still struggling with absolute value. This, type 3, will not be due till next, no, not next. Let's say Friday. No, next. Delete the next. It's going to be due this Friday. It's going to be due this Friday. Because think about it, right? You have the study guide. The study guide is tonight's priority. What's tomorrow? Test. No homework tomorrow night, except this. And if you didn't finish any of the study guide, which to do well on the test, I hope you finish the study guide tonight and go watch my video. But between now and Friday, we really don't have much in terms of homework other than studying and this. So for tomorrow, the priority is to have the study guide done for the test. Tomorrow night, if you've gotten the study guide done, then this. Wednesday, do I even see you for a class? No. So what could you still be working on? This. And then I'll finally see you for real Thursday. But what's Thursday? It's a half day. We are going to start Unit 2 on Thursday, so don't miss Thursday. But you have time is what I'm saying. Missy's going to pass out the study guide. I will pass this out. When is this due? Friday. When's the study guide due? I'm hoping that you have it ready to turn in for tomorrow because it means you'll be the best, most ready as possible for the test. But if you end up needing a little more time to wrap a question up, you can still keep it. Yes. The study guide is a little meaty, but it's more because there's a lot of space built in to show your work. But again, what am I going to put online tonight? A full video talking through the entire study guide. So choose what you'll start on. If you're still struggling a little bit with absolute value, I would work on some of the absolute value type 3. Otherwise, I would jump right into the review. You're welcome. We have a solid 5 minutes before the end of class. Let's make sure we are working hard. Decide where you're going to start. We'll be around to answer any questions. Yes. Yes. Today after school is a great day to stay. It's my longer day. I will be working with the Gear Up program for SAT prep. So my Monday, Wednesday availability may change based on that program. Today is actually the first day of Gear Up. So if you come, I may need to like bring you to where I'm working with the SAT kids and I can still help you. But that means that Remind is going to be a much more important part of your getting help from me because I'll be tutoring for the SAT. Yes. As soon as I can make it. The question was, when is the video going to be up? I promise no later than 5. Right? Great job today. Go ahead and start. We'll be around for questions. Test tomorrow. Test tomorrow. Test tomorrow.